Okay, so we are still in section 6.2, where we are looking at factoring trinomials in the form of x squared plus bx plus c. However, what you will notice is that some of the trinomials that we're going to factor will have a few curves. So we're going to explore the two basic type of curves that can be thrown at you in questions like this. And actually there are three, but we're going to explore the two that may throw you for a loop, the two basic ones. The first one will come back to the question that we looked at earlier in a modified form, in the form of a to the third minus a to the second minus 72a. In this question, what is different about this is it is not in the form of x squared plus bx plus c. The a coefficient here is still 1, but we don't have an x squared or a variable squared term here. It's raised to the third. So the main trick to this question is we need to factor out a common factor first. So I'm going to go ahead and I'm going to factor a out of this. And once I factor out a, this is going to give me a to the second minus a minus 72. As was shown in the last video, we show how this trinomial gives us the pair of factors a minus 9 times a plus 8. If you want to see how this is factored, please refer back to the previous video where that is clearly demonstrated. So the takeaway from this example is very simply to show what is the step necessary to be able to factor this completely through. So one curve is you have to factor out a greatest common factor that is a variable. Another type of curve may involve another type of factoring of the greatest common factor. Let's take a look at question 28. This is going to be 5y to the second minus 40y plus 35. So we factored a question very similar to this. However, again, you will notice that the a coefficient here is not equal to 1. Well, that is because we need to factor out a greatest common factor, which for 5, 40, and 35 is 5. And we're going to go ahead and take care of that now. So let's go ahead and go through and let's see what our new coefficients will be. Well, 5 times 1 is 5, so that'll be 5 times y squared. 5 times 8 is 40. We'll bring the y down. And then 5 times 7 is 35. So now we have 5 times y squared minus 8y plus 7. Also in the previous video, we factored a problem very similar to this, in fact virtually identical to this, maybe with a different variable, but still the same coefficients, where by factoring the trinomial and the two binomials, we would obtain y minus 7 times y minus 1. If you would like to go back to the previous video to see how we obtain these factors, please do so. Again, the focus of this particular lesson is not to show you how to factor trinomials, but simply to expose you to the type of curves that can be thrown in these type of problems. So one curve is to have to factor out the greatest common factor, which could be a variable. Another potential curve could be to factor out a greatest common factor, which could be a number. Another curve which could be thrown, and I didn't think to show this one earlier, but it would be a good time to show this. Let's go ahead and take a look at, not 33, 37. So sometimes we have trinomials to factor that contain two variables, and it looks something like this. P squared minus 5pq minus 24q squared. So you notice that the first term contains a p squared. The second term, or the third term, contains a q squared. In this type of a question, we're going to go ahead and we're going to treat the coefficient in front of p squared as the a coefficient, being equal to 1. The b coefficient will be set equal to negative 5, and the c coefficient is going to be set equal to negative 24. We will still do exactly the same work with the x box over here, where we have a times c, and we have b here, where we look for two numbers that have a product of negative 24 and two numbers that have a difference of negative 5. So all that work's going to be the same. So two numbers that have a difference of negative 24. So let's not do 1 times 24. The difference is 23. 2 times 12. The difference is 10. Let's do negative 3 times plus 8 and 3 times negative 8. We'll just stop there and let's see what their differences are. Negative 3 plus 8, if I add these together, will give me a difference of positive 5. Right number, wrong sign. However, positive 3 plus negative 8 will give me a difference of negative 5. So we have the two numbers plus 3 and negative 8 here. So what about the p squared and the q squared? Let's take a look at what we need to do to front load these before we bring the numbers back. So we know that we get p squared by multiplying p times p. We get q squared. Now I know this is 24, just wait. We get q squared by multiplying q times q. Notice I put it at the end of each of these binomials. So we're going to take the numbers plus 3 and minus 8 and put them in. So now we have p plus 3q times p minus 8q. And yes, if you multiply positive 3q times negative 8q, their product will be negative 24q squared. So the main trick to this is to simply write the p's in, write the q's in, obtain the numbers the same way. Be sure that when you are looking at these problems online for your homework, that you pay special attention to this video, as most of the tricks to the questions that are a higher level of order of difficulty will be shown here. Please see me in class if you have any questions.